So I'll get you started with the first one, just so you can kind of see what the deal is, right? So what can you say if as x goes to infinity, let's look at each of these terms in the first limit. X squared obviously goes to infinity, right? What happens to e to the negative x? As x goes to infinity, what happens to e to the negative x? Who remembers what happens to e to the negative x?
Does it equal to 1?
It doesn't go to 1. You're thinking of e to the 0, which is 1. But e to the negative infinity, right, goes to 0, right? Here's the graph of y equals e to the negative x. So as x goes to infinity, we get 0. So this limit looks like what? It looks like infinity times 0. Uh-oh. So from the beginning of the lecture, who remembers? I want to use L'Hopital's rule, but what do you have to do first? Why can you not use L'Hopital's rule quite just yet? Right, so Miriam says it has to be in quotient form, right? It's not yet in the form of a quotient. So your first step is write the limit in the form of a quotient and then use L'Hopital's rule. Okay, and then try to apply the same sort of reasoning to parts B and C. So I'm going to give you a few minutes to at least do part A. And if you finish part A, obviously move on, but I'm only expecting you to at least finish part A. By the way, in case you're curious like I am, Google Translate, is always a fun thing to see. So it translated Andy's thing as ha ha ha. Okay, makes sense. Pranav it translated as smile laugh. And Sapir's, which is Hebrew, it translated as LOL, not ha ha ha, or like something. It translated as literally LOL.
No, it is ha ha ha. I don't know.
Yeah, I know. Google translates. I didn't even think Google Translate would give you internet slang, but it told me, oh, this means LOL. I'm like, that's not a word, Google. Anyways, that's a good part there. So we have to get this in form of a quotient, right? So we have 0 times infinity. Or sorry, it's actually technically how I've written it, infinity times 0. So we write as a quotient first. So who wants to write this as a quotient for us?
I did x squared over e to the x.
Yeah, I think that's the easiest way. There's not a unique way to write this as a quotient. Obviously, I could also write it as e to the negative x over x to the negative 2, but that seems way more complicated than it has to be, right? It's probably easier just to write it as x squared over e to the x. Okay, now as x goes to infinity, if you did your algebra right, you should have an indeterminate quotient. And in fact, here we have what? We have infinity over infinity. So we're all good for L'Hopital's rule. And we get 2x over e to the x. Okay, that's fine because we just get infinity over infinity again, right? As x goes to infinity. So I can use L'Hopital's rule a second time. And as x goes to infinity, now I get what? 2 over infinity, which I know to be 0, right? 2 over a very, very, very large, an arbitrarily large number should be arbitrarily small. So we've seen something like that before. Okay. Now looking at part B. So part B is actually very similar, right? Except it's x going to negative infinity. How did you approach this limit? What do you think about that?
I mean, but wouldn't 2 over negative infinity still be around? Wouldn't it be 0 approaching from the left?
Okay, so Jitesh is basically saying it's the same exact work as before, right? You get up to this point, and you still end up with essentially 2 over negative infinity, and you get 0. I think that's what Jitesh was saying. It's basically the previous work. Do we agree? Do we disagree? I see some scowled faces on camera. Some people don't agree.
Isn't it different because when x is approaching negative infinity, e to the negative x is positive infinity?
Okay, very good. And like Kai said in chat, so exactly what Dina said, right? As x goes to negative infinity, the e to the negative x doesn't go to 0. And like Kai said, it's not indeterminate, right? X squared, that goes to infinity. But what happens to e to the negative x? Dina just told us that goes to infinity, right? E to the negative infinity, e to the infinity. But infinity times infinity is not indeterminate. Infinity times infinity is just infinity. So there's no L'Hopital's rule. There's nothing here. This is just, that's it. It's infinity. So what did I warn all of you? Before you start applying L'Hopital's rule, you have to make sure you actually can use L'Hopital's rule. This is a case where you cannot use